get started directly onto the PLSQL and then see how it is going to work. See, basically, when you talk about the PLSQL, basically the PLSQL is required if you are working with Oracle data warehouses. Basically, you might have to write some programs to perform some activities rather than doing it in Informatica. If you are using the the Teradata or SQL Server, all these things, then probably you don't need a PL/SQL at all. So if your project they are using Teradata, then we'll focus on the using of utilities, how to invoke the utilities from Informatica and all those that you are interested. And they'll also write some programs also like BTEX scripts. There also you can define a procedures. But if you understand one language, one database PLSQL language, it is same across all the things. Like if you do it in the Informatica, if you do it in the Oracle, or if you do it in Teradata or SQL Server, everywhere it is the same. You don't have any difference when you do it from one to another. So basically now what I'll show you is what kind of procedures that you actually require in a PLSQL and how to invoke that PL/SQL procedures from Informatica, that we will discuss. So as you might be knowing already, like PLSQL is an Oracle proprietary language and which does not work with other databases. I can't write a PL/SQL in the SQL Server. I can't write a PL/SQL in the Teradata. So these things will not happen. It's basically more on the, it works only with the Oracle database. And PLSQL also, if you're comfortable with SQL, PLSQL is nothing. It's just that you have to understand the syntax and use them, that's it. There is no much difference in terms of a PL. So PL stands for a procedural logic structured query language. So basically, we use a different kinds of control structures, right? If clause, else block, if else condition, else if, and then the loops, for loop, do loop, and everything. So these kind of things are generally which are being used. I mean, these kind of things are, you need to learn those syntaxes and apply all those syntaxes directly in the PLSQL. Okay, so Oracle contains a PLSQL engine by default. Like whenever you execute a PL/SQL program, that engine actually separates the procedural logic statements what you write in a program and then the SQL statement in a program. So the SQL statements will be executed by the SQL engine in Oracle database, and the procedural logic statements will get executed by the PL/SQL engine. So it will execute a query in the database, get that data, process according to your logic, and then perform the action. That is what is a PL/SQL. So basically the PLSQL, you can write the three types of programs in the PLSQL. One is called as a basic anonymous block. Which is not stored in the database. I mean, like when you actually create this program, it doesn't store. And another thing is like a procedure, and next one is like a function what you want to be. So now, so when you see that procedure and the function, so procedure and functions, basically when you create them, it will get compiled and stored in the database. But anonymous block is something that when you create the program, it will never get stored in the database. That's why the procedure and function are called as the stored programs, and this is called as an anonymous block. Anonymous which doesn't have any name. Okay, so we'll try to write a simple anonymous block to perform some addition operation by taking two integer numbers. So how you're going to do that? So in a way that I'll also explain you what are the different blocks that you see, or what are the different blocks that you see in the PL/SQL program. That also we'll understand. Suppose let's say we'll have a declaration section where we actually declare variables and everything, and we'll have a begin for this, and we'll also go about the end. That's it. So this is called as an execution block, which is a mandatory. Without this, you can't write a program. Okay, and this is called as a declaration section where you'll actually declare the variables, cursors, whatever you require. And within the execution block, you'll also have another block called as an exception section. Okay, so exception section, which it is there. Basically, this is there. So exception as well as declaration section are an optional ones. I can write a program without defining an exception. I can write a program without defining a declaration, but I cannot write a program without defining an execution block. So this is a mandatory block. Begin and end is a mandatory for a program. Exception is an optional one. Declare is an optional one which you have. Suppose, let's say, if you want to declare the variables, I can declare a variable something like this, a number, and I can initialize that with a 10. So this is called as an assignment operator in the PL/SQL, and every statement in the PL/SQL will end by the semicolon. What it is there. And when you talk about this one, let's say, see, just like your C language, you can't declare the variables. So in C language and all, what you can do, int a comma b comma c, 10 variables of integer type you can declare once, but in the PL/SQL it doesn't allow. You have to declare one by one variable. I can't declare a multiple variables of the same family together in the PL/SQL. It doesn't allow. So I can't. What I'm trying to say, like, I cannot say that a comma b number type. That I cannot do. So, and this is also reverse. In C and all, you can say that int a comma int b or like that you'll define. But here, first the variable followed by the data type. And this is an assignment operator. It's very simple. I mean, if you're assigning a numbers, directly give it. If it is a character, enclose in the single quotes. That is common thing which you have. Let's say even this also, I want to provide it as this. Let's say that is what we have. So I want to define another variable. Let's say C. This is also a number data type, which is this. As I said, each and every statement in the PL/SQL should enclose with a semicolon. Without semicolon, I mean, compiler understands that, okay, this line is ending here, first line is ending here, second line is ending here, and based on that. Now, let's say I want to assign, let's say, a plus b, arithmetic operators, logical operators, your DML statements, and the select statements, you can directly use them. You don't have any restriction, like arithmetic operators, like logical operators like and all, and suppose if you want to use anything like DML statements like insert, update, delete and all, you can directly use them within the PL/SQL. So that's why you can embed all the sequels here, but only the restriction in the PL/SQL is that you can't write a DDL statement directly. For that you need to actually use the dynamic SQL. So the dynamic SQL part we'll discuss in the later section. So static SQL and all, you can directly write it. Okay, so in the Java, the way how you have system.out.println for printing the messages and everything, in the PL/SQL you have an API, so which is called as a dbms output.put_line. So what dbms output.put_line, so basically the sum of two numbers is, so whatever you have, so basically just print them and understand in this. So this is what which you have. Suppose, let's say, exception block, you can write it. So the default exception block you can always keep. So the default, whenever there is an error, you can actually handle that error. So let's say when others, that means in case of any other error, whatever, when you are executing that, so that you can print here. So the exception will actually carry two pseudocode columns. One is called as a SQL ERRM, which will give you the error message thrown by the database, error message, and SQL code is another one, so which will give you the SQL code which you have is a Oracle error code. So for each and every error in database is associated with one code or a one number. It will give you that error code what we have. So Oracle error code is actually associated with this. So SQL ERRM is another error message, Oracle error message which you have. Suppose if there is any other error, I just want to print that SQL ERRM here. So basically this, and you have this one is called as an SQL ERRM. I'm just printing it. So if you just want to print even the SQL code also, I can just print it just for our information. This is your SQL code which it is there. Okay. So try to go through let's try to execute this and see how it is going to work. Anonymous block is completed, but I'm not able to see the result here, what it is not printing it. So in order to basically turn on the output, DBMS output. You can actually go into edit, yes, view. So there is something called as a DBMS output. If we need to turn on this actually for a particular user, so whatever it is there, now it will print that DBMS output. So this is what is it? Sum of this is a 30. Suppose let's say I'll define this as a number of 1. So do you think that there will be an exception now? I'm assigning it as a 10 and 20. The result is more than 1 digit, right? Result is more than 1 digit and you're actually assigning it to the C value. There will be an exception and that exception will be caught over here and then it will print that error message, whatever it is there. So if you try to see that now, so if you see, this is what is the error what you have. Sorry, PL SQL numeric overflow error. This is the error what you got now. So too large, number precision is too large. And this is the error code what it is printed. And this is a complete error message written by this SQL ERR. Okay, so you'll also have a predefined exceptions as well. Predefined exceptions in the sense. Okay, we'll try to write that, some program. See, whatever the anonymous block that I'm actually executing, right? So this anonymous block will not stored in the database. Every time you execute, that time only it will compile and that time only it will execute. Okay, basically the compilation and execution will happen at every time you execute the program. Okay, so suppose let's say there is some syntax error like this. Okay, when you try to execute, so since it is not compiled, while executing itself it will throw the error. See, there is another semicolon which you have put. Because of that there is another error which you have. So this is how you can create a simple anonymous block for writing the simple program what it is there. I'm going to send you all the programs what we built. And the second one is, let's try to build an anonymous block. I'm going to pass an employee ID. It has to print the employee name and the salary. I'll pass the employee ID as a input. It has to print employee name, or let's say the last name and the salary of an employee. So how do you write the select statement? That is what we'll understand from here. Declare. So let's say begin, which you have declare and then the begin, and you also have, let's say, end. And for every program, it's always good to write an exception block. So without an exception block, if you write, your program will result in an abnormal termination. So it doesn't give you the proper meaning and all. Okay. So we'll try to write the program now. Basically, I need to print the last name and the salary. So I'll define two variables. I'll define that as v underscore last name. So basically, I can also define the variable like this. Okay, employees dot last name, employees dot last name percentage time. So what does that mean? So basically, if you define the variable of this type, basically what Oracle validates is that it will go to this table, find out what is the data type of this, and same data type will be assigned to that. That is the meaning of that. Table name dot column name percentage time. So if you try to, let's say, if you try to use another thing, let's say v underscore salary. So basically, if you'd like to define another way, like employees dot salary percentage type. So basically, this is another one which you have. Now, basically, I just want to pass the employee ID. So I'll call this as v underscore employee ID, which it is there. And this is of number, let's say the number of 10. Let's say this is equal to, I'm giving it as ampersand 1. Basically, ampersand 1 is nothing but at the runtime it will prompt to enter the value. Ampersand is for a substitution of the variable. Okay, so this you can use it in SQL also. Ampersand 1, if you use it, will ask you enter the value for 1. You just enter that. Or if you just say that ampersand employee ID, it will say that enter the value for employee ID. Like that. Now I need to fetch the last name and the salary of an employee based on the employee ID which I provide. See, one thing I said is you can use a select statement. Okay, select statement we can't use it like this. Okay, select from, and let's say the employees table, and where basically the employee ID is equal to v underscore employee ID what we have. So v underscore employee ID what we have. So if you try to see, let's say the into, so I need to, you cannot directly use like this. I mean, basically this is a programming language. If whatever the data that is written by your query, where it is, where are you catching that? How the result of this statement will go and sit, where it will go and sit. You cannot write directly the select statement, but it has to be used with the select into clause. When you say the select into clause, you need to refer this, let's say select into. Whatever the data that it is selecting, it will write them into this. But the position of the variables and everything that you have to take care. So last name you should catch to last name only, and salary that you catch that into the salary column, whatever it is there. Like this you have to keep. It is not like catching the last name to salary and then this to that. You have to take care of the position, whatever it is there, right? So now I'm going to print this here. Let's say I just want to print the last name and the salary. Okay. So to do that, I'll copy the same dbms output dot putln. So what is going to, this is the last name, sorry, last name is, or probably we'll write something like this. I just want to print the last name, and let's say, and I also want to, and salary is whatever the value that we have, we're going to print that salary value also here. So let's say I want to print the salary column as well. So now this is what it is. It basically prints the last name is this and the salary is so and so. Okay. Now in case if there is an exception, so as I said, you have some predefined exceptions. Like predefined exceptions are like, suppose if your query doesn't return a data. Okay. If your query doesn't return a data, what will happen? What value will be assigned to this? Suppose if I am passing the employee ID some 9999. 9999 doesn't exist here. What will happen? Your select doesn't return a data. And what value will be assigned to this? It will throw the exception. So that predefined exceptions are nothing but you have no data found exception. So basically the no data found exception occurs when your select query doesn't return a data and you're not able to capture that value. And there are another one like a too many rows. Suppose assume that there are two records for the same employee 100 and your employees table is returning more than one record. So what value it will catch? So using an into statement you can catch only one value. So how it is going to work? So that is too many rows statement. Or suppose let's say you are inserting the data and you are trying to insert a duplicate record into the column on a primary key column. What kind of exception it will throw? So this kind of thing, this is another index called as a dup val on index. So this is an exception which occur, it is this. And suppose let's say you're performing an arithmetic operation and you're dividing a number by 0, which is an undefined one. So 0 divide, that is another exception called as a 0 divide is another exception what you have. So like this you have a predefined exceptions. Okay. Now all those exceptions you can handle it. I know that there might be a scenario user might pass the employee ID who is not present. So that time there is an exception. What I should reply back to the user. Okay. So basically I can write the statement here. No data found. Then so either you can print the value. If you're actually printing it, it will print it to the console only. But suppose let's say this kind of a program you're invoking from .NET, or if you're invoking from Informatica, or if you're invoking from some other place, you have to return that error message back to the program, right? So then only they can actually show that to the user. Or if you're invoking from Java, if you throw the error saying that no data found, what does the user understands? User will not be knowing that, but you should display the meaningful message saying that okay, employee ID 1000 does not exist, something like that. So how do you reply back that message back to the calling environment? So there is a method for it. which is called as a rise application error. So there is something called as a rise and application error. So that you can use and then return back that to this one. See, the numbers are right. This numbers, giving a number message, number is also important. See, Oracle is actually using all these error messages, right? I mean, error codes and everything Oracle is using. So if you use the same Oracle message, Oracle error code, then the error codes will conflict, right? So that's why the PL SQL, when you are writing a program, right, basically you need to use the numbers only from minus 20,000 to 20,999. Only in between that only you can use the numbers. Any numbers other than that, if you are using that error code, Oracle will throw the error. Because all the other error codes are used by Oracle. So they have given you only this numbers, you can use that. So that's why it is taken, whenever I use that method, right, directly it has taken 20,000. So, or you can use 20,001, something like that. So,
29,000.
Not 29,000, 20,999, 20,999.
So 20,000.
Yeah. So suppose if I give 30,000, it will throw the error. So basically, let's say employee ID does not exist. So I can write that employee ID does not exist. So suppose, let's say, when there is another one, if there is a too many rows exception, no data found is this. Let's say when there is too many rows exception, what it is there, and if you say that 20,001, let's say there is more than one employee with the same employee ID, so something like that. So I just want to write there is more than one employee with the same employee number or something, some message. Okay, something like this I just want to write. And also, always you should make sure that all the predefined exceptions are handled, then the default exception. It's not like I can write when others first, followed by the predefined exception. If when others gets true, these exceptions will not get executed. So always, you should always keep when others block in the last. When others is like a default exception what you have. When others, then, so it's a default execution block. So when others, let's say basically I just want to print the calling environment saying that, I don't know whether I can write this, I'm not very sure. I'll just try and check this SQL ARR. So this is what I just want to print. Okay, I'll just give the error message as 20,002 or something. Okay, so this is how I can define a program. Now I'll replace this employee ID at the runtime and try to see that. Okay, let's execute this. Employee ID 10, it is not there. So I should get an error message back. Okay. Too many rows, spelling is wrong. This is a compilation error, not the execution error. So let's try to write and execute again. So again I'm passing 10. Okay. The stored procedure calls, see this is error that which is returned from this. It's saying that ORR 20,000 employee ID does not exist. So if there is any, if there is a scenario like wherein if there is more than one row, too many rows will get executed. If there is any other error, this will get executed. So now let's try to test this. Our valid case, we tested a negative scenario. Positive scenario, let's test that. So if I pass 100, it should print the, again this DBMS block is gone, I think. Last name is King and the salary is this, right? So this is how you can do. I don't know whether I can doc. Okay, let's keep it this way. I don't think it'll waste time in this dragging and dropping. Okay, this is how you can actually use the exceptions and the select statement inside this. So this is, I'm just trying to give the multiple concepts in the same program instead of executing one by one example for each and everything. I'm just trying to give you the more information in the one single program here. So this is how you can handle the exception. This is how you can use the select statements. So this is called as an anonymous block. Okay, and there is something called as a row type also, like the way how you are defining a percentage type. You have something called as a row type as well. In the sense, I can declare something like this. Okay, so v underscore employee record. So I can call this as employees dot percentage row type. What does it mean is this will be able to capture all the columns inside that. So how I can write the program is, okay, I can also write some other thing like this. Okay, I can say this. Okay, here we are capturing only the last name and salary, right? Now I want to capture all the attributes. Okay, so I can write like this. V underscore, let's say star. I'm pulling all the columns, and I'm going to capture all these columns into this. This is a record type. Record type means entire row. This is called as an object in the PLSQL. Object. Okay. Now you have got all these values. How do I print? By using a column name. So basically I can just write it here. So now you need to access the last name column. So here I can use that last name here like this. Record type variable dot column name, and here again the dot salary, what it is there. So what we have. So this is how you can write it. Okay, let's try to print it. Anyway, I'll pass the valid example. Now I'm just trying to show you how the record type will work. Okay, anonymous block is executed and you want to see the output. This is the second print which is happening. So this is how you can actually create a anonymous block for handling it. Whatever the anonymous blocks that you have executed, right, it is not saved in the database. These are not the stored programs. These are the unnamed blocks which are available. So this is how you can write the program. So these are called as implicit cursors. Implicit cursors means it's like Oracle itself will define them, Oracle itself will remove it. You see, basically the cursor definition in the database terminology is that it's just a memory allocated for that query to be executed. I mean, in order to get this query get executed, Oracle will going to allocate some memory for processing that, right? That is called as a cursor. So when somebody asks you the cursor meaning, cursor is nothing but the memory area which is allocated by the program. That's called as a cursor. So there will be a limitation for a cursors, okay? That will be defined at the database level. Most of the time it will be 300, 500, and now in the recent times it would be maybe unlimited also because the programming and everything. So now we are going to see the other way of writing the programs, okay? I'm going to show you how to define a explicit cursor. Okay, cursors are actually of two types. Let me give you the examples for it. Cursors are of two types. One is implicit cursor, and another is called as an explicit cursor. What it is there. Implicit cursor, basically all the DML statements are your implicit cursor. Insert, update, delete, all these are all the implicit cursors. So when you talk about the insert, update, and then the delete, all these are all the implicit cursors. And let's say the select into statement is also an implicit cursor. So implicit cursors, you don't need to define them. You can directly use them within the PLSQL. Oracle only will allocate a memory for it. Oracle only will close that once it is processed. Within the memory, it will manage it on its own. Declaration and the definition, everything is being done by the Oracle. You don't need to do anything as a programmer. So when you talk about an explicit cursors must be defined by the developer. Must be defined by developer explicitly. you must define that you must define that when it is, say that that is your explicit cursor. So this is on the implicit cursor part and explicit cursor, what it is there. Okay, so cursor has a life cycle. Okay, let me just open a explicit cursor. I already provided you the materials for this. In case if you want to refer the PL SQL materials, you have something called as a basic PL SQL fundamentals. You need to learn this. Okay, Oracle database PL SQL fundamentals. If you see, I just want to show you the basically the how can I go to the okay. Maybe I have to go very long.
The chapters also.
No, it's not there. This is opened in
PDF.
It is opened with Explorer. Windows 10, it is not the PDF file. It's directly opened in the browser.
But if you open the PDF, I think you can go to this.
What is this? Nitro Reader. No, I don't have it.
Yeah, there is a.
No, that's only I opened.
Is there a menu there? Some kind of menu?
Control G. No, it will not work, I think.
Control F will work.
No, the page.
I have a lower version of PDF. I mean, Adobe shows the website sign.
Yeah, navigator window, right? This is not Adobe. It is Nitro PDF.
Oh, okay. If you have Adobe Reader, it will show.
Nitro PDF is basically it will help you to convert Word to this, that, and all. It automatically happens. I installed it for some use, but not using that. I don't know where is the cursor chapter. Okay. So explicit cursors are basically have to be declared and used by this guy. I mean, when you want to explicitly use it, first you need to declare it. That is nothing but create a named SQL area. That is nothing but the memory, and identify the active set. I mean, what are the records which are used by that? Fetch. If the cursor is empty, close it. Otherwise, go to that record and fetch. Okay. This example will give you the better idea. First, you'll open the cursor, fetch the first record, process it, go to the second record, process it, go to the third record, process it. If the cursor runs out of cursor is empty, close the cursor. Within the loop, you have to go. Fetch the first record, process it, go to the second record, third record, fourth record, fifth record. When the cursor is empty, we just come out and then close. That is an explicit cursor. Basically, explicit cursor in the PLSQL is used to process the group of records. If you see the select into, what is the disadvantage with that? Only one row you can fetch. Suppose now if I want to print last name and the salary of all the employees who are there in the department number 90, what should I do? I should loop through that, right? So that is not possible using your select into clause. Okay, let's try to write one program. Okay, using an explicit cursor. Cursor lifecycle is that first open, fetch first declare. You need to declare the cursor in the declaration section, open it, fetch. If the result is empty, close it, else loop through. Fetch and then close. This is a life cycle of the cursor. You need to declare, define, and then access and all. So open, fetch, and the close what we have. So now let's try to print last name and the salary of employees of the department number 90. That is an example. So it's more or less the same thing, but I'll just define it by using a different way. Okay, so basically we have a declare. Let's say I'll pass this as a DEPT ID, and let's say ampersand of, let's say DEPT underscore ID. begin, end, what it is there. So basically I need to print all this. So how to define an explicit cursor is that all the explicit cursors will be declared within the declaration section only. So I'll get all these, let's say get employee is my cursor name. Each cursor will be associated with one select statement. Any select statement you can write. There is no restriction as such. Any select statement I can write, I can loop through the records written by the select statement. Okay. Here I'll write, I need to basically fetch the last name, salary, and from the employees table. So basically I'll write the condition as where department ID is equal to v underscore DEPT ID. So basically if I pass the DEPT ID, whatever it is, it has to replace that and get all the list of those things here. Now I need to print it. So basically I know that this record, this one will give me more than one record, right? So if it gives me more than one record, can I use a select into statement here? No, we cannot use. So we need to go for a looping mechanism, that is by using a basic loop. In the PLSQL you have two types of loops, three loops in fact. One is a basic loop, another is a do while loop, another is a for loop. So basically I'll show you both how to write the basic loops and how to write the for loops. Okay. So to basically do that, here what you need to do is, first you need to open the cursor, you declared it, next is open. So I'm showing you how the basic loop will occur. Okay. Loop and then the end loop, that's it. First open cursor, this is one statement, loop and end loop is in between this you have to write all those. Okay. Now what will happen? See, the cursor should come out of the loop when there is no data, right? So for coming out of that, I will go and write one statement. This is a statement you need to write whenever you use a basic loops. Exit when there is no data in the cursor. I want that to come out if there is no data. So what I'll do, I'll actually use, this is a cursor name. So there are attributes for the cursor. Okay, one is called as a percentage found, another is called as a percentage not found. Exit when, get percentage not found. Okay, this is okay. Now what I'm saying is, if there is no data in it, just come out of the loop. There is no data inside that, come out of the loop, don't process anything. There is no data, what are you going to fetch? Okay, so I'm writing that this statement is must when you use a basic loop. But in case of a for loop and all, you don't need to do, it will take care automatically. We'll see that how it works. Okay. Now, in order to fetch the result, what is the statement? Fetch. What is a cursor name? This is a cursor name. What attributes you are fetching from it? Into what attributes you are fetching? Let's say the last name and the salary. So we'll write last name and we'll write the salary as well. Okay. Now I just want to print this last name and the salary. Okay. So I'll just print as is. Whatever the statement that we have written here, I'll just go and copy paste the same statement. So I need to print within the loop because multiple records, right? I need to print within the loop. So let's say this is your programming what you have. So now once you are done with this, let's say close the cursor. You need to close, right? So that is for using a close statement and then do it. See, if you see the basic loop, you are opening the cursor, you are only coming out of the cursor using exit when statement, and then after processing the data, and then you are closing it and then do it. So in case any exception is there, I'll just go and write the same statement. Okay. Whatever that you have, all these exception block, I'm going to copy paste. If there is a no data found exception, do something. If there is a too many rows exception, do something, or whatever is applicable that you can kept. If these two are not applicable, this is not applicable, we are sure that it will give only one row, not more than one row. So let's say this, you can keep it. Now this is a PLSQL program where we have defined a explicit cursor and then we are processing the multiple records. Now if I pass the department ID, basically it has to print all that. Okay, so what I'll do is I'll just try and execute, and let's say the department number 90. Okay, so it is executed. Let's see the output, DBMS output. Okay, this is the data. Last name is King and the salary is 24,000. Last name is Kocher and the salary is 17,000. Last name is Dihan and the salary. I think there are 4 records inside that. That's why it is printed. Maybe, or it's printed twice. Is there a possibility that it will print twice? Yes. What does it will do? Maybe the last record is getting printed twice. Okay, we'll see that from here. There are only 3 records, but it is printing twice. Okay. So Dihan is getting printed twice. So what we should do now is, okay, so your program, you have to print, you're fetching the result and you're printing it. Yeah, that's correct. This is a place for it to print. This is correct. I don't know why it is printing. 4th record. Okay, I'll try to keep this. Not sure. Okay, we'll execute it one more time and see whether it is printing twice or it's just okay. Department number 50. We'll enter the DBMS output. Yes, it's printing twice. Why last record is getting printed twice? Okay, we'll understand that. Okay, now your exit when it is not found, so it will come out of the loop, and the fetch statement, what is it?
Can we use the exit
After that.
Before the end loop?
Once you fetch it and then print it. Okay. Basically that should be here, fetch the data and then do it. So here only it has to jump out of the loop, otherwise it is printing for the last record twice. So let's try to check this again. Let's say this time 90 and view the DBMS output. It's fine. So basically this is what is about how to use the explicit cursors inside this to use that. And how to use a for loop, I'll directly show you when we are writing a programs. Okay, so this is what is about the basic explicit cursor example, how to print the multiple values, and this is how you can use a basic loop. Okay, so that is the use of the basic loop. Now so far what we have seen is only the procedures, but there are the other storage blocks in that. I mean, so far we have talked about anonymous blocks. Now I'm going to talk about the procedures and functions. Okay, so far any questions? Any questions to start? Now basically this is just to help you to understand the fundamentals of the PL SQL. We're not going in very deep and understanding each and everything what is there in the PL SQL. Okay. So just to make yourself comfortable, I'm just trying to cover all the topics in a precise manner. Okay. So let's try to understand what do you mean by the procedure and what do you mean by the function. Basically there are 2 programmatical blocks what you have. One is called as a procedure and another is called as a function what we have. So when you talk about the procedure, basically the procedure is something that where it may return the data or it may return the output value or it may not. That's an optional in case of a procedure. It may or may not return the data. So may or may not return the data by the procedure. So when you talk about the function must return the data. Function must return the data when you talk about this one. So when you talk about the procedures and functions, how you define them and how you pass the inputs and all, that we'll see now. Okay. So what is basically the use of procedures and functions in case of a data warehousing projects? Why should you write that? There is already the Informatica is there, which can actually perform all the transformation logic. It can insert the data, update the data, delete the data, it can read it, do whatever the action that you want. Then what is the use of that? So basically in the data warehousing environments, procedure is used to drop the indexes, to create the indexes, or analyze the tables and all those things. So you can say the question like, I can use a pre-SQL, I can use a post-SQL for dropping the index and recreating the index. Why should I write the procedure for it? If you're actually handling through the procedure, it will be centralized and you'll be able to manage it effectively. What happens is, I'll give you a practical scenario why procedure will be benefitable instead of using a pre-SQL and the post-SQL. What will happen? Suppose let's say you have actually in the pre-SQL you have written some 10 indexes are there in my fact table. I've kept all the 10 indexes. I'm dropping it, I'm recreating them in the post-SQL. What happens because of the performance? Your DBA has created one more index. Later part of time in the production, they have created one more index in that. What is the case? What is the impact for it? You need to go and modify wherever you are loading that fact table, right? So if it is being used in the 10 mappings, I have to go and edit the 10 mappings every time I add an index, which is a difficult task, right? In the production environment, you can't do that. So if you're actually dropping the procedure, dropping the indexes through the procedures and functions, then it is easy. You can actually centralize that activity and I can do it in an effective way. So that is the reason procedures are used in the data warehousing environments. Basically, it is being used to drop the indexes, and basically it is used to create the indexes again back on the table, create indexes, and you also use the analyze the tables, and sometimes the procedures are used to truncate the partitions, exchange the data between the partitions and all those. So for these reasons, we will use truncating the partitions and suppose exchange the data between the tables or exchange the data between the partitions, what you see. So this is what you have and how you go and save it. Okay, these are all the uses of it, and if you're actually doing through the procedure, it will be very easy. Now what I'm going to do is I'm going to define the procedures for all these, and I'm going to invoke all the procedures from Informatica. That's it. That's a very simple thing. Okay, so what we'll do is first we'll create all these procedures in the database level. Let's test those, and then I'll show you how to invoke it from the Informatica. It's a very simple task. Okay. So I'll show you one of the procedure how it can be implemented. Remaining all the other things you can invoke it. Okay. So now we'll write a procedure for dropping the indexes. Basically, suppose you know about the system tables, right? Basically, if I want to know how many indexes are created on the table, I can go and refer the system table and understand that, okay, there are some 10 indexes are there in that table. Okay. Basically, that information is already available in your data dictionaries and system tables. Okay. So what I'll do is I'm going to define a procedure. What that procedure does is it will read the data from your data dictionaries. I'll pass the table name to that. It should read all the indexes which are defined on that table, and it should drop all the indexes. That is my procedure should do it for me. If I pass the table name, Go and fetch all the indexes from the system tables, drop all the indexes. Okay, and while dropping the index, if there is any error, you just return back that error back to the calling environment. That is what it has to be done. So I'll create a procedure now. So this is a syntax that you need to create. So create or replace. So what is the meaning of create or replace is that if the procedure is already existing, you go and replace that. If the procedure is not there, you create it. That is the use of that. Create or replace the procedure. Create or replace the procedure. Let's say we call it as sp underscore drop indexes. Sp underscore drop indexes. Let's say we call this as table name, p underscore table name. This is a input argument. See, for a procedure, you can pass the inputs. So inputs are of three types: input mode, in-out mode, and the output mode. So like if I define an input, that parameter can be used, or that argument can be used only to pass the input to the procedure. If I say in-out, I can pass the input, at the same time I can get the output from it. If I define out, it only out, no in. That is the meaning. By default, even if you don't define anything, let's say if I say that as varchar2, that is an input. By default, that is the meaning of that. So let's say I need to also get the error message. So basically use error message, and this is also called as a varchar2 what it is. And this one is an out parameter, and this one is an in-out parameter or input parameter which I know. So is and begin and end the procedure, that is from the drop indexes what it is there. So basically here you can declare the variables, handle the exception, and everything is the same except this syntax. Everything else is the same what we have learned. Okay, so now what I'll do is I need to drop the indexes based on the table name. So what I need one here in this procedure. I'm going to teach you how the dynamic SQL can be used. Dynamic SQL means, see, till the runtime you don't know what index you have to drop, right? How many indexes you have to drop, and what is the index name you have to drop, you don't know. Based on the table name only, it will be determined at the runtime. So here input is not static, it is dynamic, right? So if I pass employee table might be having 10 indexes with the 10 different names. That names can be determined only at the runtime. See, suppose if I say, now I want you to define a table, truncate the table based on the input. You don't know what table you have to truncate, right? I cannot write the statement like this. Truncate table p underscore table name. You don't know what is p underscore table name is going to be. I can pass A, B, C, D. Input is not static. If I saying that truncate employee, you can go and write truncate employee table. But table name you don't know. So this is called as a dynamic SQL. Means where input for the statement is determined based on the result or based on the input that you're going to pass. So that is called as a dynamic SQL. So this dynamic SQL is used here for dropping, because you don't know the indexes, you don't know the table name, what it is, and all those things. Runtime, whatever is going to be defined at the runtime. And one more thing is that you can't use the DDL statements inside a PL/SQL directly. DDL statements should be used only with a dynamic SQL. So that dynamic SQL can be executed by using a statement called as an execute immediate. So this is a syntax which is used, that is called as an execute immediate, and you can give the table name like this. I mean, drop table A. I can write like this. Execute immediate and then use this. So basically what I'm trying to say, you cannot write this statement directly inside a PL/SQL like this. Drop table A. It should be passed with a execute immediate statement. That's what I'm trying to say. Okay. Now for that I'm defining one variable called as a v underscore SQL. This I call it as varchar2 of, let's say, 1000, which it is. Now I need to fetch all the indexes based on the table name. Which data dictionary view will store the indexes information in the Oracle. That is nothing but a user underscore indexes. There is one data dictionary view which stores. So I'm going to use that index, that one. So cursor, so basically cursor, let's say get indexes is, let's say basically the select, you have something called as an index name from, what is indexes where it is stored, user underscore indexes, where table name is equal to, in order to understand the structure you can query that. Okay, suppose if you are not familiar with the structure and table name, so that you can use. Okay, now this cursor has all the indexes which I have to drop, right? And I'll drop one by one index. That's it within the loop. Okay, so it's very simple, and we'll also write a exception block. Okay, and here you don't need to use a declare keyword here. That's an optional one. If you declare also, that's fine. Even if you don't declare also, that's fine. So this I can write it, or you can even take out also. That's fine. Now here I'll see that for, so I'm using a for loop this time. Last time I used the basic loop. I'm using a for loop this time. So you can use any counter variable, something like this. Any variable that you declare, that is an implicit declaration. You don't need to define that in case of a for loop, which is common across all the languages. We'll write in C for I in 10, 1, 2, 3. I you are not declaring anywhere, but you're just, that's called as an implicit declaration. Okay. So for I in, basically it has to rec in this, and then it has to go through all the indexes. I'll write like this, loop, and then the end loop. So what is the advantage of the for loop is that you don't need to open, you don't need to close, you don't need to use a fetch statement also. Directly you can write. But if you see the old one, see here, open, loop, fetch, close, all these things are not required in case of for loop. For loop, if you are writing, directly you can do that. So now, here I need to use the VSQL. Basically, I'm going to prepare the SQL statement that I'm going to execute. What is the syntax to drop the index? Drop index name. Okay, so what I'll use? Drop index. I don't know what is the index name. Till runtime, I don't know. Right? So I'm going to use rec dot. This can be accessed something like this, rec dot index name. So at runtime that will be replaced. My SQL statement will become drop index idx1, drop index idx2, drop index idx2, and all those. Now I need to execute that SQL statement. That is your drop statement. I'll use this execute immediate, and then anyway that SQL statement is already stored here. I'll write this. So if there is an error while dropping the index, so I'll write this as when others, then. So basically I need to return the error message back to that calling environment. So I'll write this as p underscore error message. See, basically suppose if you are invoking this procedure from Informatica, that error message should be displayed in the session log, right? What error message it is returning and all. So that error message I'm returning back to this, saying that SQL ERRM. So this will tell me what error message it is, right? So we have seen, right, that one SQL ERRM. We already declare. Understand this. What do you meaning of SQL ERRM? It is nothing but an Oracle error message. So that Oracle error message value, that I am assigning it here. That Oracle error message value, I am assigning it here. So this is how you can define the procedure. So I'm going to compile the stored procedure now. Okay. So let me compile the stored procedure. Okay, there is an error. We'll try to address that now. So all the procedures can be viewed from here. Okay, this is an error of my procedure. Okay, what is it? I think declare is not accepted. I don't know. Okay, let's try to do that. Now it is compiled. Declare is not required when you are defining a procedure. Okay, so now it is compiled. Okay, so what it should do, this procedure is doing, if I pass the table name, it has to drop the index. It's as simple as that. If there is an error, just return back me the error message what you got. Okay. Now, basically, let me try to test this. Okay. What I'll do is I'll pass one table name, and when I pass that table name, basically if there is a error, it has to drop that. Okay, see, there is a primary key and there is an index also for it. See here, there is an index for it. What I'll do is to test my procedure now, I'll pass the one table name, that is your ODS underscore employee. Okay, so it has to drop that index, whatever is there in the ODS employee table. If there is an error, it has to throw me that error what it is there. So one thing in Oracle, I'm not sure about other databases. You cannot drop the index which is defined for a primary key. Basically, what happens in this database is that whenever you define a primary key, primary index is automatically created. Okay, so without disabling the primary key, you can't drop that index. Now my primary key is active on the ODS underscore employee table, and this is an index which I have shown you now is a primary key index. If I try to drop that without disabling the primary key, it will throw me the error. Now let's see whether it will throw me the error or not. So executed, go to output variables. This is an error which is thrown by this. What error it is throwing? Cannot drop the index used for the enforcement of the primary key or a unique key. It is not able to drop. Okay. Now we'll test it with some other example now. Okay. Let's go to the fact sales table and see whether it has any indexes. No, it doesn't have any indexes here. So what I'll do is, just for testing purpose, okay, I'll create one index here. In this there is a error. Okay, let's correct that. So for a testing purpose, we'll just create one index. Okay. Okay. Create index name, let's say IDX underscore representative ID. I'm creating a index on a representative ID column on, let's say, the fact sales. We have a column called as a rep ID. Okay, so this is called as a rep ID, and try to create that, and you have got that index which is created. Now the index is created here. Basically, I'll go and pass that table name here. Anyway, the table, index is here. So if you want to check, cross check once, index is available. Okay. So now here, instead of ODS employee, this time I'll pass the fact sales as an employee. So when you try to do this, so no error, go back and check, this index should have been dropped, right? It is being dropped from the backend. So this is how you can define the procedure to drop the indexes. Now I don't need to do anything. All I need to do is that invoke this procedure from the mapping and do it. That will take care of all the dropping of indexes part. That is how you can do it. Alright. So any questions so far? Okay, I'll show you how to invoke from Informatica, but at least at the backend level that you can see that. Similarly, you can create a procedure for creating indexes, analyzing tables and all those. Okay, for that you already have the stored procedure. Okay, what we'll do is I'll just explain you how this works. Okay, create indexes stored procedure, or let's do that. Otherwise, let's do that very quickly. Okay, see, now the very interesting thing that you have to know here is, when you drop the index, what will happen? All the indexes information which is there in your database is gone. Now how do you create the indexes? Same name, but what is the column name? Which column? What type of index? That information is not there. Then how do you handle that? So you're dropping the index and you have to create the indexes also. How do you handle this kind of a scenario? Any idea? So if it is the case that disable the index and enable the index, that is fine. Information is already there. You are disabling it, load the data and then enabling it. But here we are dropping it. Information is not there. So how do you handle that? So this kind of a methodology is followed in the real time. What we do is, whenever we are creating any index, we'll maintain all the indexes information in some metadata table. So we will define one metadata table. In that metadata table, I'm going to define what is the table name, what is the column name, what is the index name, what is the type of index that you want to create. That information will be there. So whenever you are creating any new index, you need to go and add an index name in that, so that you will keep track of that index information which it is there. So based on that in metadata table, we'll start creating the indexes. Okay. Now what I'll do is, there is one table called as a DB indexes. Okay. I don't know whether I have. No, it's not a system table. We have to define it. It's not a system table. We need to define that over there. I don't know whether, where did I kept that? No, every time I keep somewhere and forget all this. Okay, one second. There was a batch which we have taken. Okay. So if I go back for August weekend, no, not this one. There was something called as a PLSQL. Okay. Anyway, we have that information. At least this time I'll save. Okay. So in order to practice that, right, creating indexes information, what I will do is, for creating indexes, you need to define one. This part, not this one. We need to define one table basically. That table is nothing but the DB indexes table. I don't think that is available here. Okay. What we'll do is, I have that information already, but just to show you, I'll actually drop that and recreate it. In my database, I already have, because I already created that table. That table name is DB indexes. What it has is an index name, table name, and the column name. What I'll do, I'll go and take this table definition from here. Okay. And what I'll do here is, I'll create that table. Okay. So even though this table is already existing, what I'll do, I'll drop it and recreate. Okay. Okay. Before that, let's also collect the insert statement for it. Export, insert. I need a SQL statement. I don't know whether it will give or not. Okay. This is a SQL statement what I have. I need this also before dropping. Okay. So what I will do is, this is what it is there, and this is what we have. Okay. Now I'm dropping. You have to do the same exercise. Okay, in your schema, because to make it very simple, what I'm doing is, I'm dropping drop table, right? So I'm dropping the table, and dropping the table is this, and I'm dropping this table DB indexes. Okay, when you try to do this is dropped. Okay, now I'm going to create that table back again. Your sample metadata table. This is okay. Now you do that, and the index information. Basically, see, on the fact sales table only this information is there. Rep IDX is a index name, table name is fact sales, and the column name is representative ID. Similarly, the second index name, when_IDX, fact sales, vendor ID. Likewise, if you want to define 100 indexes on the table, go and insert the metadata into that. This information should be present. So this is like a one-time activity. You don't need to do every day. When I'm defining a table, I've decided that, okay, I want to create 10 indexes. All 10 indexes information, I'm going to keep it here. Okay. So that 10 indexes information, once you keep it, and basically next time when your DBA is adding a new index, what will happen? We should ask them, okay, go and first add it here and create it. Or they don't need to do creation also. If they just add it as part of everyday load, what will happen? That index will get created. Right? That index will get created. So basically what I'm doing now, I'm going to create this table. Okay, it's already there. So I'm going to insert this metadata to those tables and commit the data. Okay, commit the data, what it is there. So basically now what I'll do is, I'll go and use and create index procedure. I need to basically do that. That procedure is already there. I'll just explain you how it works. Okay. Create indexes part. Basically what you need to do is, you need to define one cursor, read the index name and the column name and the table name. Okay, index name and the column name you're going to get from this. Basically go through the loop and create one by one index. What is the syntax for creating an index? Create index name on table of column name. So that's the same statement I just prepared here, and I'm just executing that immediate SQL. So it will basically drop the index. So what I'll do is I'll take this. Anyway, I'll ask Gangadhar to send you this thing. Okay. So this is a index one. So let's compile this stored procedure. Now the procedure is compiled. So you go and see here. This is my procedure. Let's test this. See, we have defined the indexes for a fact sales. What will happen? I'm going to define the fact sales from here. So try to do that. Now these indexes should have been created in my fact sales table. Go and check here. Where is the fact sales table? Now if I go here on the fact sales, go to the indexes. Two indexes are created by this. So this is how you can actually use the creation of indexes stored procedure. Similarly, analyzing the tables. What is the use of analyzing the tables? Okay, do you have any questions on this so far?
One question, not particularly related to this, but in a stored proc, suppose you wanted to return the line number and the current procedure name as a generic way, right, in the when others, so it will work for all procedures. It will give the name. The one thing I can do is every procedure beginning I can say my name is equal to this, but so the name and the line number where the error happens, is there some kind of a predefined variables or something which you can
Line number, if you want to capture, at each and every place you need to maintain one variable and keep initializing that.
Okay.
Line number, if you have to capture, at what place the error is actually occurring, if you want to understand. That what happens in PLSQL is that we'll define one variable, we'll write it as before beginning of the loop, after ending of the loop. In that way you can understand where it is actually occurring, or inside the loop, in which all those things can be maintained by using a best practice of exception handling, that is called as a best practice. So just by looking at the error message I can understand in this part there is an error which is occurred. But if you have to return the procedure name, one method is that what you said is you have to initialize that a procedure name, but other way I don't know. Maybe I have worked on PL/SQL very long time back. It's almost 6 years back I worked. So I don't know, maybe some name, maybe now they might have introduced some pseudo column.
I saw there is something called PL/SQL unit, but if it is in a package, it
No,
returns
PL/SQL unit. Okay, PL/SQL unit.
I mean, like SQL error and SQL the error code, it would be nice if they get
Name of the procedure.
okay, let's see.
Yeah, that's the same thing. PL/SQL unit. You can define it or you can use a PL/SQL unit. I don't know. Maybe this again you need to pass.
Or there is PL/SQL line also. Okay, I have to try that out.
PL/SQL unit and PL/SQL line.
And there is $, like Informatica.
Maybe that they want to differentiate, like from a normal variable or a pseudo column or a data type kind of thing. That's a reason. That's the one. Okay, that's a new thing which I see. Okay, so that's how we can create the indexes back by using that. What is the need of analyzing the tables? I just want to understand, like, why do you need to analyze the tables basically? See, need of analyzing the tables in the data warehouse is that basically analyzing the tables every day your Oracle will capture the statistics of the table, like how much volume of data is available, how many indexes are present in what column. All those information internally it will save into some table. That's called the data dictionary. Whenever you execute a program, it has to choose the optimal path to read the data. I mean, best path to read the data. So if you're analyzing it every day, your statistics will be of up to date, and it will choose always the best path to read the data. So Oracle best practice is that if you analyze the tables every day, your statistics are up to date, so your performance of that reading of the data will be very good. So that is the reason in Informatica projects and all, what we do is at the end of every day load, we analyze the table. We analyze that table so that information will be already captured, and then the data retrieval at the reporting level will be fast. So that is the use of that analyzed table. So that's why we take care of the analyzing part itself. It's a very simple. You can analyze the table as well as you can analyze the schema also. Completely whole tables, I want to do it only once. You can do analyze schema name. You give it, all the objects will be analyzed in it. So basically for that also we have one stored procedure, and it is the same thing. It just takes a table name. It is just a very simple statement. That's it. Analyze table name and compute the statistics. So you pass the table name, it will analyze not even a loop also, because you are passing only one table name. So it will analyze it and then do it. So this is also one thing that which we generally use in the Informatica projects. So if you go and see the analyze tables, that's what which it is there. You can also compile that and keep it as part of this one. So this is what for a schema you can give. I don't know what is the syntax, but generally schema is not recommended to use because it takes a hell lot of time. Because if you have some 100 tables, what will happen? 100 tables have to analyze means it will take a long time, but you can do that. Analyze schema in Oracle eventually. So basically you can also analyze the indexes, clusters, everything that can be used. So schema also can be used. Analyze schema, get schema, gather schema stats, but it is by using a procedure, but you can also use it as a direct DDL statement as well. So what it is there. So that's based on the different way of defining these procedures. And I'll just show you one example for function, and with that we will close it. So basically the function, see, procedures here we have defined as we are passing the input, we are getting the output. That is an optional. I mean, without passing input also I can define a procedure, but function must return a value. Okay, let's try to define one function where it will actually calculate the total salary of the department by taking the department ID. I'll pass the department ID to that. It must return me the value, that is the total salary. So it's a very simple thing. Create or replace function. So let's say f underscore get total salary, f underscore get total salary. I'll pass it as p underscore department ID. Let's say input, which is called as a number, what it is there. So is, let's say, begin and end this function. Basically one thing that we have to remember is that function must return the value. So you must define the data type, which data type it will return and all. So what type of value it will return. So that is going to be the return and number what you have. So basically now we'll try to define this. So basically which we call it as v underscore, let's say v underscore total salary, which is of number data type. Let's say number of 10 which you have, and I'll just define a direct value. Select sum of the salary into v underscore total salary from, let's say, employees, where department ID is equal to p underscore department ID. So now I need to return the total salary here. So just return the value what you have actually captured. Return v underscore total salary. And in case of any exception, I want this to return 0. So if there is any exception, which it is there, exception when others, then return 0 what you have. So basically this is what we have, and now just compile. See, one thing with a function is that functions can also be invoked from the SQL statement. You can also use them in the SQL. Suppose if you want to calculate, run, let's say the department ID is 10, get that, it will give you the total salary 4,400. So basically this you can also define, and I can also call the function from the the select statement. I can write something like this: select department underscore name, let's say the f underscore get total salary, department underscore ID, let's say total sal from, let's say employees, sorry, departments. So if you just want to see that, which it is here, just execute and then do. So this is how I don't know, for this null is becoming because there is no exception. These departments are not present in the employee table. So that's why it is returning a null value. So this is more like how to define a function and how to do it. Okay. So we can probably take a break for 10 minutes and come back, and we will discuss what is the package and what are the components are available in the package, and I'll show you the stored procedure transformation, how to invoke from Informatica. With that, we'll end the PLC. Okay. You can come back maybe in 10 minutes because it's a programming language. Next part, that is like what is a package and what are the components in the package and how to compile the package and all those things. Okay. So when you see this here, let's say the package is actually of two types in this. What do you mean by the package? In the sense, like you combine all the objects into a one single unit, like variables, cursors, procedures, functions, whatever you want to use, you can keep it as part of a package. That will become like a one unit. Package has two things. One is called as a specification and another is called as a body. So specification will contain all the signature of the methods, definition of the procedures and functions, and body will contain the implementation of procedures and functions. Implementation is like implementation of procedures and functions. That is called as body. Okay. When you are compiling the package, first you need to compile the package specification, then the package body. Without package specification, you can't compile the package body. Okay. Package specification must be present for compiling the package body. When you talk about can a package specification exist without a body? Yes. I can compile only the specification. Body is not required. I can define only the specification for it. That can be done. Now, what is the advantage of packages? Why can't I keep on defining my standalone procedures? Why should I actually keep procedures into a package? See, basically what happens is that if you define a standalone procedure, whenever you execute a procedure contents will be loaded into the memory and then it will process the data. When you go for this one, basically the package contents will be loaded only once into the memory. Whenever you call for the first time, that time it will load it into the memory and then it will reuse because it will be available in all the memory and everything. Basically, in a package you have a group of procedures, right? So even if you invoke any one procedure, it will load all the package contents. So it will be easier for you. Suppose if you are invoking any other procedure which is part of a package, it don't need to load it again because it is already available. So that way it is advantageous. Okay, that is called as a package specification and what you do it. And when you talk about the basically that is the advantage of the package. So how do you define a package specification and the body is that? It's very simple. And when you're defining a specification, only give that. So create or replace package. Let's say I want to define a package. What is it? Is ETL package. That is the name of the package. So is end of the package. So this is where the package is ending. So in the package specification, as I said, you'll define only the method definition. So basically, if I have to keep this method, I can keep only the definition of it, like this. And suppose, let's say procedure, another procedure, create procedure I want to define. So I can just define it like this. And let's say the drop indexes procedure, if I want to define, I can keep this one like this, which you have. And so basically now you have these things. So whatever the method that you define in the package specification, that is a public method. If you are defining only in the package body, that is a private method. Okay. So let's try to compile this. So now it is compiled. So what I'm saying is you can define your own variables, cursors, everything here. That will become public, which can be used anywhere, whatever they want. Or constants, anything you can define, that can be there. So when you talk about the compiling that package body, so it's just that. So create or replace package body. And here I'll define the complete implementation part of that. So whatever it is there, you can just keep on defining. Let's say the procedure, I want to define this as well. So you can define, let's say the create indexes procedure. I can even define this as well. And basically the end and what is a package name. So package name, this you can define the package name. See, if you see the function definition, I have not defined that in the package specification, right? You don't have it, but I'm defining directly in the body. So I can define like this. This is like a private. Private means it can be used within the package. It cannot be used outside the package. Suppose if you want to invoke it from Informatica, you can't do that. If you want to invoke from Java, you can't do that because it's not a public method. It's a private method. So private methods are used within the package only, not outside the package. But if you define that in the package specification, that is like a public. Invoke it from anywhere, Java, Informatica, anywhere you can invoke it. So that is the difference between a private method and a public method. So now if I want to compile this body, basically I can just compile this package body. Now the package body is compiled. So can I compile the package body first and the specification next? No, that's not possible. First always the specification, then the body, followed by the body. So whatever you define here, it will appear here. Util package, if you go here, so this is a package and this is a body of the contents. Why it is not appearing here, that one, function? Because that's a private one. That's why it is not appearing. Even if you go and see in the body, see here how it is appearing, because that's a private method. They are showing it a different icon, that's it. This is how you can compile create a package specification in the body. So if you are keeping the methods into the body, package and all, maintenance will become easy. Suppose if you have 1,000 procedures, if you see, it will be very big, and compilation, handling that will become different. So if you keep module by module, packages and everything, it will be easier for you to do that. So that is basic use of the packages and the package body what you have. So this is more about the packages, how you define the PL SQL packages which you have. Okay. Let me save that into this Informatica Labs PDF guide so that everybody can refer. So PL SQL and PL SQL dot whatever the SQL. So this is how you can define all those and then maintain it. Okay, that's the end of your PL SQL. So till the packages. So whatever we have learned, that is it. Now, see, so far what we have understand is we are concentrated in PL SQL features, how to define it and all those. But how we are going to invoke this from Informatica? That is handled by using a transformation called as a stored procedure transformation. So using this stored procedure transformation, you can invoke the procedures which are defined in the DB2, Sybase, SQL Server, Informatics, Oracle, anywhere you define the stored procedure. It is compatible, I think, with 5 or 6 databases. You can define a stored procedure and you can invoke that stored procedure from Informatica. So stored procedure transformation is like, it can be configured just like your lookup. One is like a connected lookup and another is called as an unconnected lookup, what it is there. Connected lookup and how you call it as unconnected lookup, which it is. Sorry. So connected stored procedure, unconnected stored procedure, which we have. Okay. So now how to invoke it? I'll show you one example. Basically the dropping the indexes stored procedure. We already have in the fact sales, we already have the indexes. I'll try to drop these indexes by invoking that. Okay. So how do we define the mapping? So basically, if I go to the 961, let me open the designer and log into the this one. So basically, if you have it, and so now this is my working folder. So let me define, see, what is your stored procedure is taking? It just, if you see the drop indexes stored procedure, it is basically taking a table name and error message. I need to pass the table name. How can I pass the table name? I don't have any table in my database which will give me just the table name where I can actually pass that. So in order to do that, what I'll do is I'll create some dummy source definition, so which I call it as stored procedure underscore input something, and this is an Oracle table. I'll just use this as an Oracle table. So click on create and then done. So here, and so which I call, let's say I'm just adding a table name, and this is going to be the varchar2 of 30. So this is a, I know that there is no table called as a sp underscore ip in my Oracle database. Okay, I'm going to use this table definition as an input, and if the stored procedure returns some error, I'm going to write that into some flat file, dummy flat file. If it returns an error message, I'll write into some dummy flat file. So for that also I'll creating some flat file. So sp underscore output. So in this, I'm going to have one column called as a error message. Error message, what it is there. So just apply and click on OK. Now I'll define a mapping. So this is just a mapping which I am creating for dropping the indexes what we have. So click on create. So drag and drop the Oracle table what you have defined, and now create the stored procedure transformation. If I go here, there is something called as import stored procedure, or you can go and select the stored procedure transformation and do anything is fine. Suppose let's say if I want to go by this option, Where is your stored procedure is available? It is there in my target schema. Select, input this one which you have. So the procedures, this is, see that function is not visible because it's a private, right? That's why it's not visible. So drop the indexes. Now looking at the stored procedure, I can easily understand what input it is taking and what output it is giving, right? Now I need to pass the table name. So just pass this table name here. And in case my stored procedure returns an error, I have to print that error message part of the session log. Otherwise, if you are just writing it to a flat file, what is the problem? Your session will always show it as a succeeded status only. But you'll not be knowing whether it has succeeded or failed, all those things will not be tracked. So you can actually write that error message into the session log. How you can do? I can use some expression transformation, which I can call it as expression underscore stored procedure. Pull this error message here, pull this error message, and what it is, this one is that this is your input, and you call this as out underscore error message. So there is a function in Informatica which I'll define it as string of 4000. This is an output port. There is a function called as an error function, abort function and all. So using this, suppose if there is an error, I want to stop the session there only. I don't want to execute further. You can use that error function. If you want to abort the session, you can also abort it. So it is that using this function, you're going to stop the session and write this error message back to them. If you use abort function, it will abort it and write that error message to the session log. Now, when should I write this error message? If not is null of error message. So basically, if my error message is not null, then I'm going to use the function. This is an error function, okay? So you can see that function from here as well. So basically, what is the use of this? It causes the current row to be skipped and the error message will be printed as part of an error message. It will print that error message in the session log. Now I want to print saying that stored procedure has returned an error. Stored procedure has returned an error, and you'll just combine that, and you're going to use that error message back here. Okay. Now it will return me the error message. What is this error message contains? It is an Oracle error which is returned from your stored procedure. Else, I'm just going to use the error message back. Okay. Now, where is it? Okay. Error message, and then I'll close it. Okay. Anyway, if that is not true, it is just a null value, right? So I'll just write that error message back to my stored procedure output. Now I'll use that stored procedure output which it is there, and this is what which I have. Save it. Now if you try and see this, this is what is the input what we have. So basically now if I look at this, what kind of query will be generated? If I see this, this is a query which will be generated to my database. Whether I have this SPIP table, it doesn't have. You know about dual table in Oracle? It's just a dummy table. If you pass anything, it will give the same output back. Okay. So this table, I'm going to replace it with a dual. Okay. Now here instead of this complete thing, I can write, let's say, what is ODS underscore employee from dual. If you execute this query, what will happen in Oracle? It will give the same ODS employee back to you, and you will pass that ODS underscore employee to your stored procedure. So if I want to make it reusable, what I should do? Yes, I'll go and define a parameter and pass that parameter over here. So I'll just go here, define one parameter which I call it as, let's say, tname, and the parameter, let's say the string of 30, which it is there, and I'm going to pass this table name there. So here when you are writing a query, instead of hard coding the table name, what I'll do, I'll just replace and use that parameter here. Runtime, I'll replace it. If I want to drop any index table, just pass the parameter, invoke the same mapping, drop the index. Okay. So this I'll do it, apply and click on, okay, save it. Now it is done. So my query will be fired how it is. Runtime it will be replaced. It will say that select fact sales from dual, select ODS employee from dual, anything you can do it. Now I'll go and execute the create a workflow for this. Let's say workflow with a non-reusable session. Click on next. So SP drop indexes. Click on finish. Go to the workflow. So let's say if I go, this is my stored procedure to drop the indexes. Okay, this is reusable. Okay, I don't know whether which folder I'm in. Okay, that's fine. So let me define the everything. See, this is available everywhere. Okay, so if you just want to assign that OLTP source, you can give this. And stored procedure output, anyway flat file it will generate. For the stored procedure also you need to pass you need to assign the connection, right? It is there in my target schema. So I'll go and assign the target schema connection here. Apply, save it. Okay. Now I need to pass the table name to it. So what I'll do, I'll go and define the table name here in my Unix server. And go to the info shade, let's say the parameter files. So we have so many things. What I'll do is click on, let's say drop indexes EDW September or August, I think this much, August 2015 underscore, let's say 10 AM ist.prm, which it is there. So here I need to define that. What is my session name? I'll go here, copy the session name back and go back, define the session name. I need to pass the parameter name. And what is the parameter name that we are using here? It is a $t name. So I'll just pass $t name is equal to. So I'll just pass first the ODS underscore employee. We'll just see whether that error message will be printed, because you cannot drop the index, right? So for a primary key column you cannot drop. So what I'll do, this one, so let's say this is a parameter file what we have, and go to the properties tab, pass the parameter file. What is the name of the parameter file name? That you will capture it from here. And this is my parameter file name. Go and define this. Let's go and add it. Apply the change and click on OK. Save it, which you have. So now if I run it, it should actually fail my session, right? Because primary key index cannot be dropped. So let's see that how it will work. So it has to fail that session. So I'll go back here and check, get the previous runs. This is failed. See the error here. Stored procedure has returned an error, cannot drop the index which is used for the enforcement. If you're not using that error function, you can't see that error here. Basically, they'll just write that error message to the flag file and it will show here as succeeded. You'll not know. Unless you go and check that file, you're not sure that whether it has dropped the index or not. So you must use that function, whatever it is. Now we'll go and then let's change the parameter file. What we need to do that. So let's say if I am writing this fact sales, so save it. So now it has to drop the indexes what we have defined. So see here, I have 2 indexes. If I run it, it should get succeeded and drop the indexes for it. Go and then see, dropped. And then go back and check here whether it has dropped the indexes or not. Dropped. So this is what is a use. So these things you can reuse it. Once you define for one mapping, you define for dropping the indexes, another mapping for creating, another mapping for analyzing. All these things you can keep it to a shared object like this, and within your project that can be reused. Within your project that can be reused. I mean, in this it is not there, but if you go here, I mean, anyway, workflow sessions and all cannot be reused, only the mappings. So if you go here, this way it can be. So all these things you can define in a shared folder and drag and drop, create a shortcut for all these and reuse them. So that's how you can allow the reusability for it. So this is more about the connected stored procedure, how to do it. Unconnected is very simple again. Let's say if I have to show you an unconnected stored procedure, unconnected stored procedure which you have, unconnected stored procedure. So click on this. Now unconnected means just invoke it from Informatica. So how do you do that? Let's say this is an error message that you want to capture. I'll define one variable port and I'll call that from the variable port. So home, let's say v underscore error message. This is a variable port, all right, which I'm going to use it as :sp dot. What is the stored procedure transformation name you are given? It is util underscore pkg underscore sp underscore drop indexes. What input it is taking? It is taking the table name as an input. I'll come back to this. Okay. Let it be. Table name as an input. Do we have the table name here? No. Let me pass that. Let's say, let me pass the table name back. Okay. This is my table name. Here, I'm going to process that. Okay. Basically, I need to pass the table name and it is returning one error message, right? How to catch that error message? It is returning one output parameter. I have to catch that output parameter when I'm invoking. So for that, you have something called as a proc result. Proc result is a value. When it will invoke, it will capture that value returned into the proc result, and that proc result value will be assigned to your error message. This is how you need to do. And now this error message, whatever you have, I'll just assign this to a output port and just do it as an output port. Now pass this error message, whatever you have. I mean, it is the same again. Basically, if you have that error message value is null, do this and all. I mean, you would have avoided.
What result you have to capture in this?
What?
Error message you have to. Is a proc result is needed here, right? If not, is null proc. Yeah.
One second. I don't think that is required at all. Okay. Now just connect that error message back to here. So this is an unconnected stored procedure where you're not connecting, you're going to invoke it from. So this is more on the unconnected stored procedure. Just define it and then do it.
The expression, what was done here? So you're calling that and just passing one input. And how you're getting that error message?
It will get that error message in the proc result, right?
Oh, proc. Okay, that is a built-in thing.
Yeah, built in.
And
That proc result value will be assigned to this error message.
oh, okay. That's
And that error message is I'm using it in the below output. Right? Okay, so that's the end of the story.
I think there is the unconnected lookup, mapping lookup. The connected lookup can be used only for this mapping. Unconnected lookup can be used for multiple mappings.
If you are defining it within the designer, mapping designer, it can be used only within that mapping. But if you are defining it in the transformation developer, it can be used anywhere.
Okay.
If you are defining in transformation developer, no, connected, it cannot be connected, right? It's just the transformation. So if you are defining it in a transformation developer, whatever it is, it can be reused across the multiple mappings. But if you are defining any transformation, thumb rule is that it is just a scope is that only for that mapping, not for multiple mappings. So that's it, what I have to just to talk about the stored procedure transformation and all those things. One more thing about the stored procedure is that when it is unconnected, it can be invoked in multiple ways. It's like normal means whenever it is invoked, it will get executed. You can also define it in this way: target preload, target post load, source preload, source post load. What is the meaning of target preload is that if I define it before loading the data into target, it will execute the stored procedure. If I say that source post load, after reading the data, it will invoke. But you have to define that call text here. What input you are passing and all those, you have to pass it here. That. But you can make your stored procedure transformation to be executed at any time based on the normal execution or based on the target preload, source post load, target preload, target post load. Anytime you can execute if it is unconnected. You don't need to call that. You don't need to call that from expression. I can just set it as target preload, automatically, implicitly it will invoke. That is the advantage of the target preload and all. But if you are selecting the target preload, you must write that call text. How you call the stored procedure is that just provide the stored procedure name and then pass the inputs. That you need to pass it. But for this procedure, you can't do it because it is returning an output, right? If it is not returning an output, you can call. That is about the stored procedure transformation, how you use that. And suppose you want to use a group of functions, which is like, let's say the phone number. Okay, in US and all, what the phone number they display is, they display it like this. Okay, how it is 001. In iPhone and all, you see that it will store it in this way. Let's say 415 iPhone, let's say 8974, something like that. I mean, this is 10 numbers, right? Okay, 4567, something like that they store. Basically, in the phone number, in this format it is stored. Suppose if you have a normal phone number, and in the report they want to display the phone number like this. They wanted phone number to be displayed. So if you want to achieve this, basically you can use a substring function, use the hyphen and all those things that you can do it. Basically, if you have to use it every time, phone number might be the customer phone number, employee phone number, vendor phone number, supplier phone number, or anybody's phone number will be there. You might use that phone number format in thousands of places. So every time you cannot write that entire substring function to use it. Instead of that, I can define one user defined function. I can just access that anywhere, wherever I want. So what I'll do is now I'll define a function called as a format phone number. I'll define one function. So this I want to make it as a public, means anybody can use it. No return type, nothing. It doesn't give any return type. It will just give you the value whatever you want. So the input argument, let's say input argument name is phone number. Phone number. What is the data type of this is, let's say phone number will be always an integer, right? So, but the output, where I can write output. Why? Okay, public cannot be there. Okay, let's say what I mean private. And what is this one is that basically it has to return. So 001 it has to append. Let's say 001 is not there. You just want to display 415 hyphen like that. So use a substring function. So substring of, let's say substring of phone number. You can use this substring of phone number, comma 1, comma 3. First 3 you want to display it like that. Then you need to use the hyphen. Okay. Then it has to use again substring of phone number. Let's say the 4, comma 3 again. So again hyphen. Let's say again you use a substring of, let's say 6 or 7. What is it? 7, right? Substring of phone number and then 7 till whatever the numbers. Let's say you want to read only 4 numbers, you can define 4. So just validate this. This is valid, but why it is not valid? Syntax error.
By default, I put 3 seconds before bracket. Open bracket.
Where?
The second phone number, valid 4,3, just before the port.
Here.
It's the bracket.
Not required.
It's valid.
It's valid. Okay. Now this format phone number, whatever you define, that is available there, right? Suppose if I want to use that user defined function as part of this. Okay. If I go here to the user defined function, you will see that. Just use that function and pass the phone number. It will give the format in that. And that's how the user defined function can be used. Suppose a zip code validation. You want to do the zip code validation saying that, okay, zip code should be always, US zip codes are always 5 digits. And it must be the number. And you want to do all those validations. You can do that validation and then so. That's how you can define one user defined function. Wherever you have a zip code, pass that. So zip code validation, you are defining one user defined function. It returns true if the zip code is valid. It returns false if the zip code is not valid. Based on that you want to do. Define one user defined function, invoke it just like a normal function. That is the use of that. That's it.
Public in the sense, whoever is having access for that particular folder, only they can.
I think the public is more like, okay, I'll tell you.
Any other user also can use it.
No, public is like you can use that user defined function as part of one more user defined function. I have defined function 1. I want to make that function 1 to be a part of function 2. Nesting function. That you can do it. Private means it's only, it cannot be called from any other function. That is the meaning. That's the user defined function. Okay. Any other questions? Okay. So probably I'll wind up for now. Any other questions from Vinay? Your end?